Hello guys, how are you? Myself Sudha, studying third year MBBS in AIIMS Nagpur. See, we are starting this chapter alcohol, phenols and ethers. This is comes under organic chemistry. See, to understand this chapter, first you have to be thorough in GOC. Then only you can understand this chapter very well. So I will suggest you guys to study GOC very well. Then only study about this chapter. See, without any delay, let's start the topic. See, first question is ethylene oxide when treated with Grignard reagent yields. See, this Grignard reagent is RMGX. See, the polarity of bond is decided by electronegativity difference between them. See, Mg is more electropositive, so it has the tendency to lose electron. So Mg will be positive and R will be negative. So R will be a nucleophile and Mg positive X will be a electrophile. So when it reacts with ethylene oxide, the formula of ethylene oxide is CH2 and it is enclosed by O. The polarity of this is O negative and carbon positive. So when these bonds break and it reacts with RMGX, then it produces CH2 R CH2 O MGX. When this product undergo hydrolysis, hydration and it undergo hydrolysis, it produces R CH2 OH plus MgHX. It produces this one. Though how we can say this is whether it is primary, secondary, tertiary alcohol. See, whenever hydroxyl group attaches to the primary carbon, it is known as primary alcohol. When hydroxyl group is attached to the secondary carbon, it is secondary alcohol. When hydroxyl group is attached to the tertiary carbon, it is known as tertiary alcohol. See here, this carbon is primary carbon and this is secondary carbon. So hydroxyl group is attached to the primary carbon. So it is primary alcohol. Whenever this ethylene oxide reacts with a Grignard reagent, it produces primary alcohol. See, Grignard reagent is used for production of alcohol. Industrial reagent it is. Industrial reagent. So the option will be C. Whenever Grignard reagent reacted with ethylene oxide, it produces primary alcohol. It will be C. Second question. Which of the following will not form a yellow precipitate on heating with an alkaline solution of iodine? C. Alkaline solution of iodine is iodoform, that is I2OH minus. It is known as iodoform salt. See, iodoform salt. Which group reacts with iodoform salt? It is carbonyl group. Carbonyl group. This includes CO, CH3 group. Only this presence of this group in the molecule, it gives yellow precipitate on reaction. Yellow precipitate on reaction. See, whenever primary is reacted, CH3, CH2, OH, it produces CH3, CHO. It includes CO, CH3, H. So it includes carbonyl group. So whenever primary alcohol reacts, it gives yellow precipitate. In case of secondary also, C, CH, CH3. Whenever it reacts, it gives CH3, CH, it will be C double bond O. C double bond O, CH3. It also contains carbonyl group. So Secondary also produces yellow precipitate. But in case of tertiary, in case of tertiary, see, whenever this alcohol is removed, this undergo dehydration. Not it does not produce aldehyde group, yeah, ketone group or carbonyl group. So whenever tertiary alcohol reacts, it does not produce yellow precipitate. So we have to find the option where it contains tertiary alcohol. See, option A includes CH3, CH, OH, CH3. See, when it reacts, it produces CH3, CH, C double bond O, CH3, C double bond O, CH3. So it contains carbonyl group. So it produces yellow precipitate. Next one, option B, CH3, CH2, CH, OH, CH3. It is also a secondary alcohol. So it produces CH3, CH2, C double bond O, CH3. In case of third one, it is a methanol. So whenever methanol reacts, it does not produce yellow precipitate. In case of option D, CH3, CH2, OH. Whenever it reacts, it produces CH3, C double bond OH. It also contains carbonyl group. So it also produces yellow precipitate. So option will be C. Next question. Which of the following is correct? Option A. On reduction of any aldehyde, secondary alcohol is formed. Next. Option B. Reduction of vegetable oil with H2SO4 gives glycerin. Option C. Sucrose on reaction with NaCl gives sugar. Option D. Alcoholic hydrogen iodine gives iodoform with NaOH. C. On reduction of any aldehyde. For example, RCHO reduces. It produces ROH. It produces primary alcohol. For example, ketone, when it is reduces, it produces secondary alcohol. When in case of, for example, in next one, in case of tertiary alcohol, tertiary aldehyde, see, where aldehyde produces alcohol on introduction, it may be either primary or secondary. So option A is wrong. Option B, reaction of vegetable oil with H2SO4. See, what does vegetable oil contains? Vegetable oil contains fat. It contains triglycerides. What does fat contain? It contains triglycerides. Whenever it is reacted with H2SO4, it produces fatty acid and glycerol, not glycerin. So the option B is also wrong. Next, option C, sucrose. On reaction with NaCl, it gives inert sugar. See, whenever we all know that sucrose is a disaccharide. So what does sucrose contains? Glucose and fructose. Whenever it undergo hydrolysis, it produces glucose plus fructose. What is the rotatory value of sucrose is dextrose plus 62.5 degrees. What is the value of glucose? Dextrose plus 52.5 degrees. What is the value of fructose? It is levose minus 90. So from 6 plus 62.5, it produces minus 40 of net rotation. So from dextrose, it is converting into levose. So there is inversion of sugar is taking place. Next one, option D. Alcoholic iodine gives iodoform with NaOH. See, whenever, for example, take CH3, CH2, OH. Whenever it reacts with I2 plus NaOH, it produces yellow precipitate. See, We all know that CH3 CH2OH, it converts into CH3 CH4. So it contains one carbonyl group. So it contains carbonyl group. So it produces yellow precipitate. Why CH3OH does not give yellow precipitate? Because whenever it converts, it produces formaldehyde, HCHO. So it does not contain carbonyl group. So it does not give yellow precipitate. Next question. Propane 1-ol may be prepared by the reaction of propene with C. From propene, they need propanol C. How propene can be written? CH3, CH, double bond, CH2. So propene will be one propene. 1, 2, 3. At first position, we have double bond. So it is one propene. They need one propanol C. CH3, CH2, CH2OH. This is a primary alcohol because hydroxyl group is attached to the carbon which is attached to only one carbon. That's why it is primary alcohol. See how it takes place. CH3, C, double bond, CH2. So whenever this bond shift, one will get negative, one will get positive. How the bond shifting takes place? See how it also, which one will be useful to produce alcohol. See, whenever it reacts with B2H6, NaOH, H2O2. See, B2H6, it will be BH2H twice. It produces, in this attaches, it is an addition reaction. Addition reaction because double bond is eliminated and in the place of double bond, new groups are added. In the place of double bond, new groups are added. So it is known as addition reaction. So it follows anti-Markovnikov rule because here hydrogen, that is proton is added to the carbon which has less number of hydrogen. What is Markovnikov rule? Where proton is added to the carbon which has more number of hydrogen. So it follows anti-Markovnikov rule. So where hydrogen is attached, that is CH3, CH2 and CH2, BH2. And it further reacts with CH3, CH double bond CH2. It produces CH3, CH2, CH2 twice and BH. And further reaction with CH3, CH double bond CH2. It produces CH3, CH, CH2. This is B. This is CH3, CH, CH2. And this will be CH2, CH2 and CH3. On further it reacts with sodium hydroxide and hydrogen peroxide. There will be breakage of these bonds. So it produces primary alcohol. CH3, CH2, CH2OH plus BOH 3 twice. So from the conversion of propene to propanol, it requires B2H6, NaOH and H2O2. In this, we learned anti-Markovnikov rules and Markovnikov rules and addition reaction. See, what is this? It means hydrogen, that is proton, is attached to the carbon which has less number of hydrogen. In this, proton is attached to the carbon which has more number of hydrogen. So option will be C. Next one. They're asking the stablest among the following. Stablest among the following. What is option A? CH3, CH. It contains OH twice. Option B. CH3. It contains CH, CH2, Cl, CH, OH twice. Option C. CH3 are twice and OH are twice. Option D. Instead of hydrogen, it contains chlorine and CH, OH, and OH. See, in this OH is a electron withdrawing group. So OH and Cl are electron withdrawing group. OH and Cl. This contains minus I effect. What is minus I effect? It is inductive effect. Inductive effect. Minus I suggests these groups are electron withdrawing groups. Electron withdrawing groups. What is meant by plus I effect? Plus of I effect means these are electron releasing groups. See, minus I effect means these are electron withdrawing groups, and plus I means electron releasing groups. See, every option contains OH, so OH doesn't make significant difference in these options. And let's see Cl. In this case, option D has 3 Cl and option B has 1 Cl. How the stability of the atom is measured? Stability is measured by electron density and steric hindrance and presence of electron withdrawing groups. Presence of electron withdrawing groups. See, this carbon, it is attached to OH and CH3, and this carbon is attached to CH2, Cl, and OH. See, steric hindrance is almost same in all options, so steric hindrance doesn't make much difference. And option C, presence of electron withdrawing groups. See, we all know that OH and Cl both are electron withdrawing groups, but in all options it contains 2 OH groups because so that it does not make much difference. But see about Cl. See, in option D we have 3 Cl groups, so which makes the atom more stable. So option D contains 3 Cl minus groups. Cl exhibit minus I effect, which makes the atom stable. So it will be option D. Next question. Which one of the following on oxidation gives a ketone? See, we all know that alcohol on oxidation, it produces aldehyde and ketone. On further oxidation, it produces carboxylic acid. See, what are the oxidizing reagent? Oxidizing reagent, it will be potassium permanganate, which is a strong one. So it does not stop in intermediate one. It finally converts alcohol to carboxylic acid, which is a strong oxidizing agent. So it converts alcohol into carboxylic acid. And so it will be potassium dichromate, and potassium permanganate is also a strong oxidizing reagent. So it also directly converts alcohol into carboxylic acid. So whenever there is a strong oxidizing agent, it does not stop in between the steps. When first alcohol is oxidized, it produces aldehyde and ketone. On further oxidation of aldehyde and ketone, it produces carboxylic acid. So what are other oxidizing agents present? It will be chromium oxide. It will be CrO3. It is a weak oxidizing reagent, so it can convert alcohol into aldehyde and ketone, and it does not convert aldehyde ketone on further oxidation. It cannot produce carboxylic acid. So it is a weak oxidizing agent, so it stops in between the step, that is aldehyde or ketone. And another oxidizing agent is copper at 573 degrees Celsius. It also acts as oxidizing agent. For example, whenever primary alcohol RCOH, it undergoes oxidizing agent in the presence of CrO3. It produces RC double bond OH. It produces aldehyde. So primary alcohol gives aldehyde, and whenever secondary alcohol it undergo oxidation, it produces ketone. So secondary alcohol produce ketone, and tertiary alcohol, whenever it reacts, it does not produce any aldehyde or ketone. Rather, it undergo dehydration reaction. So it produces R. After removing all water, it produces R double bond R. So rather undergoing oxidation, it undergoes dehydration reaction. So tertiary or alcohols never produce aldehyde or ketone on oxidation. Rather it produces alkenes. So what is the option? Option will be secondary alcohol. We all know primary gives aldehyde, secondary gives ketone, and tertiary it does not give any aldehyde or ketone. It only gives dehydration. It undergo dehydration reaction and gives alkene. Next one. Which of the following when primary alcohol undergoes catalytic dehydrogenation? See, what is meant by dehydrogenation and hydrogenation? Hydrogenation means addition of hydrogen. Dehydrogenation means removal of hydrogen. They are asking catalytic dehydrogenation. See, removal of hydrogen in the presence of catalyst is known as catalytic dehydrogenation. Addition of hydrogen to the molecule is known as hydrogenation. See, what will be the option? Whenever primary alcohol, which option produces primary alcohol whenever it undergoes catalytic hydrogenation? See, whenever it produces CH3, for example, take for primary aldehyde, see, RCH4. Whenever it reacts with H2, so it produces ROH. It acts as reducing agent. So, so it produces primary alcohol. Next question. Methanol is industrially prepared by option A, whenever CH4 reacts with steam at 900 degrees. What it produces? It produces CO plus H2. It is known as synthesis gas. So it does not produce methanol. So option A is incorrect. Option B, reduction of HCHO using LiAH4. It also does not produce. LiAH4 is a reducing agent. And option C, whenever it reacts formaldehyde with NaOH, So it is about acid-base reaction where NaOH it produces, it acts as base, and HCHO it is a formaldehyde, it acts as acid, which produces sodium salt and releases water. So option C is also wrong. Option D. See, whenever after production of synthesis gas from methane, it on further oxidation, in presence of zinc oxide and chromium dioxide, it produces methanol. So the industrial method of production of methanol is reduction of synthesis gas in the presence of ZnO Cr2O3. See, the temperature is around 300 to 400 degrees Celsius and pressure is almost same. So in these specific conditions, we can prepare methanol from synthesis gas. How synthesis gas is prepared? Whenever steam, whenever steam reacts with methane, it produces synthesis gas. On further reaction with ZnOCr2O3, then only it can produce methanol. So it will be option D. Next question. HBr reacts fast with C. HBr. HBr. In this, the electrons are more driven towards bromine, so it makes negative and H positive. So how it is acts through SN2 reaction. So SN1 reaction. See, option A includes 2-methyl, 1-propanol. So write propane, and at first position it contains hydroxyl group, and second position it contains methyl group. Whenever the polarity between OH and C will be O minus and C positive. Whenever it releases, it can produce primary carbocation, and it shift to second position, it produces tertiary carbocation. And second option B will be 2-methyl, 2-propanol. So it contains C, C, C. At second position, it contains methyl group and OH group. So whenever it removes OH group, it produces tertiary carbocation. See this here, primary is not stable, so it shifts towards second carbon where it can be tertiary. So it positive charge is shift from first to second carbon to make it stable. And option C, propan 2-ol. It contains C, C, C. At second position, it contains hydroxyl group. So after removal of OH, it produces secondary carbocation. And third one, or fourth option, it is propan 1-ol. So at first position, it contains carboxyl group. Whenever it removes, it produces primary carbocation. After rearrangement, it produces secondary carbocation. We all know that SN1 reaction, where nucleophile is substituted. SN1 reaction, the rate of reaction is directly proportional to the stability of carbocation. We all know that, for example, C in this case, C R OH. Whenever it releases, it produces secondary carbocation. In this case, whenever it releases, it produces tertiary carbocation. It is carbocation is intermediate part. It is intermediate. Whenever the stability of carbocation is more, the rate of reaction will be more. So stability of carbocation will be tertiary is greater than secondary greater than primary. So see, in which case tertiary carbocation is forming, it is option 2. In option A, tertiary carbocation is formed after rearrangement. So option A is also wrong. Option B, after removing hydroxyl group, it directly produces tertiary carbocation. So option B will be the most fastest where HBr can react. In option C, it produces secondary. After option B, option C is the most fastest reaction. In option D, where after removal of hydroxyl group, where positive charge is present on the first carbon is shifted towards second carbon, make it secondary carbocation. So what is the option? It is option B. It is tertiary carbocation. So it will be B. Next one. Propene CH3CH double bond 2 can be converted into 1-propanol by oxidation. Indicate which set of reagents amongst the following is ideal to affect the above configuration. See, they are asking propene is converted into 1-propanol. 1-propanol means hydroxyl group is at first carbon, so it is 1-propanol, and propene means double bond is at first carbon, so it is 1-propene. So they are asking which is the ideal reagent used for conversion. So we all know that whenever propene reacts with B2H6 in the presence of H2O2 and NaOH or OH alkaline media, see, whenever it undergoes, it is addition reaction. Addition reaction. So it is BH2H twice. What it produces? See, double bond is removed. So it is an addition reaction. It is CH3CH addition reaction, and it follows anti-Morkin route where H plus is added to the carbon which has low number of hydrogen. So where H is added, it is added at this second position. So it will be CH3CH2, and BH2 will be added at first position. It is CH2 and BH2. Further reactions, on further series of reaction, what it produces? It produces CHT. This hydrogen is also replaced by this propene molecule, where hydrogen is replaced by propene molecule. So it produces CH3CH2CH2 B, CH2CH2CH3 and CH2CH2CH3. On breaking of these bonds, it produces CH3CH2CH2 and alcohol. How these bonds are broken? With the help of hydrogen peroxide in alkaline media. So it produces primary alcohol plus BOH3 taken twice. So how it is converted from propene to propanol? In the presence of B2H6, hydrogen peroxide and sodium hydroxide. The most ideal reagent is C. Next question. Lucas reagent. What is meant by Lucas reagent? Lucas reagent is concentrated HCl plus anhydrous ZnCl2. See, whenever alcohol reacts with Lucas reagent, it produces alkyl halides plus turbidity. That is, white precipitate is formed. For example, primary alcohol CH2OH, when it reacts with this concentrated HCl plus ZnCl2, what it produces? RCH2Cl plus H2O, and the remaining will be white precipitate. Secondary alcohol RCH2OH plus CH3. Whenever it reacts, it produces chloride at secondary position and white precipitate. And tertiary. Whenever tertiary alcohol reacts with Lucas reagent, it produces RC, C and Cl plus white precipitate. See, tertiary carbocation is more stable than secondary carbocation is more stable than primary carbocation. See, Lucas reagent undergo SN1 reaction. So rate of reaction depends on intermediate compound. What is intermediate compound in SN1 reaction? It is carbocation is directly proportional to carbocation. cation. So whenever tertiary carbocation is present, so it reacts fastly with Lucas reagent than primary. So tertiary reaction reacts fastly rather than primary carbocation. So tertiary produce rapid rapid turbidity, and primary at room temperature it cannot react with Lucas reagent. It cannot act with Lucas reagent. What is Lucas reagent? It is concentrated HCl plus anhydrous zinc chloride salt. It is option A. Next one. Which one of the following will not be soluble in sodium hydrogen carbonate? See, what is sodium hydrogen carbonate? Sodium hydrogen carbonate, it is a base. Sodium hydrogen carbonate, it is base. When which compound will be soluble in base? It is acid. Whenever acid reacts with base, it produces salt plus water. So acid can be soluble in base. How we can tell in this option which is more acidic has tendency to soluble in this sodium bicarbonate. See, let's see options. Option A includes 2,4,6 trinitrophenol. See, what is phenol? It contains benzene ring with OH group, and they're telling at second position it contains nitro group. So it will be meta nitro group NO2 ortho para. It is ortho and para, no at meta position. So option B is benzoic acid, COOH. Option C is orthonitrophenol, OH and NO2. And next is benzene sulfonic acid, C. Nitro and NO2 groups, these are highly minus I groups. Minus I. What is mean by minus I? These are electron withdrawing groups. So they withdraw electrons from oxygen lone pair to make the bond more polar in between OH. So H can be easily donated. See, oxygen has two lone pairs, and these three are highly minus I groups. So electrons from oxygen is withdrawn. So what will be? This bond is more polar. So H plus can be easily donated. So it is more acidic. So it can be easily soluble. So option A is it can easily soluble. They are asking which will not be soluble. Next, option B. Option B includes benzoic acid. It includes COOH. We all know that after removing H from benzoic acid, it undergo resonance. See, C double bond O minus. This undergo resonance make it more stable. So hydrogen can be easily removed from benzoic acid. So it is more acidic. It has more ionization constant. So it can be soluble. So option B is wrong. Next, option C. Orthonitrophenol. 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 It includes OH, and at ortho position it includes NO2. So ortho position it includes NO2. We all know that NO2 is a highly minus I group. minus I group. So it has some minus I group. Along with that, it has hydrogen bond between H and N, so which makes difficult for removal of hydrogen from this compound. Next, option D, benzene sulfonic acid. Benzene sulfonic acid, it has high ionization potential constant, because we all know that after removing electron, it has SO3 minus, which makes which under be in resonance, so make it more stable. So make it more stable. So it can be soluble. More the acidic nature, it can react with base. Acidic nature, it can react with base. It produces salt plus water. So which will be not soluble, which has less acidic property. We all know that in orthonitrophenol, it has some hydrogen bond, which makes difficulty for removal of hydrogen from the structure. So it will be option C. Next one. Phenol is distilled with zinc dust, then followed by Friedel-Crafts alkalization with propyl chloride in presence of Al3, in presence of AlCl3 to give compound B. Compound B is oxidized in presence of air to form compound C. The structural formula of compound C is, they're asking, whenever phenol it reacts with zinc followed by Friedel-Crafts reaction with propyl chloride in presence of AlCl3. After this, it undergoes reduction. So it produces benzene. They're asking, after reduction, it undergoes Friedel-Crafts alkalization with propyl chloride. With propyl chloride, that is CCC. At first position, it has Cl in the presence of AlCl3. Then what does it produce? It produces cumene, isopropyl benzene. It produces cumene. Whenever it is oxidized in presence of air, see, whenever it is oxidized in presence of air, it produces OOH. It produces it produces cumene hydroxide. After reaction with cumene, then they're asking what is the option C. It includes C. It includes CCO. It is isopropyl presence of hydroxide group at second carbon in propene. So it will be option C. Benzene with presence of 3 carbons and presence of OOH. It will be option C. Next one. The ionization constant of phenol is higher than that of ethanol, because see, phenol, what is the structure of phenol? It is OH and ethanol, C2H5OH. They are asking why it has high ionization constant. What is meant by ionization constant? Whenever it divides, it can easily give H plus. That is known as ionization constant. More the ionization constant, more the ionization constant, more the acidity. It has more acidic nature. How why it has more ionization constant? For example, after removing hydrogen, it has one electron, minus O minus on oxygen. Whenever it is transferred here, it can produce. It is transferred here and double bond is shifted this side. It has negative charge, double bond, and double bond O. And whenever this double bond is shifted this side, it has positive here, so it can form double bond here, double bond negative, and double bond O. After shifting this bond here, it has positive charge here, and it can produce double bond double bond, O and negative. Whenever this is shifted here, it is shifted here, here positive charges appear. So double bond, O minus, double bond and double bond. So this phenoxide ion is stabilized by resonance. So H plus can be easily removed. For example, in case of ethanol, CH2OH, CH2, C2H5OH. After removing proton, it only contains ethoxide ion. So ethoxide ion is less stable as compared to phenoxide ion. So that's why phenoxide ion has more ionization constant than ethanol, than ethoxide. So that's why phenoxide has high ionization constant than ethanol oxide. So option A is phenoxide is bulkier than ethanol oxide. C. Stability is decided by resonance and steric hindrance and electron withdrawing groups, stable absence of lone pairs, because presence of lone pairs, absence of lone pairs. If it contains lone pairs, which makes it unstable. So they're asking phenoxide ion is bulkier than ethoxide. See, phenoxide ion is bulkier than ethoxide according to the steric hindrance concept. According to steric hindrance concept, which is more bulk, it will be less stable. So option A is wrong. They are telling it has high ionization constant. High ionization constant. It means it is more stable in that form. More stable. So option A is they are contradicting the statement of the question. Option B. Phenoxide ion is stronger base than ethoxide. See, ethoxide is stronger base as compared to phenoxide. See, ethoxide is stronger base as compared to phenoxide. See, after if phenol has as more acidic as compared to C2H5OH, then after removing hydrogen O minus and C2H5O minus, it has more basic nature as compared to phenoxide. It is completely reversal. If phenol has high acidic nature, the phenoxide ion it will have more basic. It is less basic. If it has more acidic, it is less basic. So see, ethoxide is stronger base as compared to phenoxide. Phenoxide is not a stronger base. It is complete reversal. If phenol has strong acidic nature, phenoxide ion has less basic nature. Next, phenoxide ion is stabilized through delocalization. See, we all know that phenoxide ion undergo resonance. Why resonance? Because oxygen has negative charge, so it undergo resonance. So it is stabilized. So option C is correct. Phenoxide is ion less stable. If phenoxide ion is less stable, it should not have ionization constant more comparatively than oxide. So it will be option C. See, what is meant by resonance effect? What is meant by resonant effect? Resonant effect is due to electron rich substance such as negative charge or presence of lone pairs. For example, see, this is Phenol, O minus, it has negative charge. For next, it it, it is COO minus. It also has negative charge, so it can also undergo resonance and make the ion stable. Make the ion stable. See, CO3 minus 2. It can also undergo O minus, O minus. The shift of charge is equally shared between three oxygens. So it also makes stable. The next one we have plus R and minus R groups. What is meant by plus R and minus R? See, whenever the group attached to the benzene molecule withdraws electron from them, withdraw electron from benzene. This is known as plus R. What is minus R? See, whenever some molecule is attached to the benzene, see, it produces O minus. See, whenever some molecule attached to the benzene, it gives electrons to the benzene group. It gives electrons. So that makes it as minus R group. These are plus R and minus R. Next one. Next question. They're asking decreasing order of acidity. H2CO3 and phenol. Options include water, C2H2 and H2CO3 and phenol. See, we all know that H2CO3 has more uh, acidic nature, less acidic nature as compared to phenol. Now only we discussed about this concept. See, in phenol, phenoxide ion is stabilized through delocalization, where in case of CO3 minus 2 is also stabilized. Here one charge is delocalized between 6 carbons, where here two charges delocalized between one carbon, 3 oxygen groups. So this is more stable as compared to CO3 minus. So acidic nature will be more in phenol as compared to H2CO3. Then how does H2 and C2H2 can be compared? We all know that in chemical bonding, in chemical bonding, more the S character, more will be acidic nature. More the S character, more will be acidic nature. What is in which we have calculate S? This is hybridization. Hybridization. See, what is the hybridization of H2O? See, what is the electronic configuration of oxygen? It is 1s2, 2s2, and 2p4. So it includes 1, 2, 1, 2, 3, 4. So electron is shifted from S. It includes 1s, it reacts with 2p molecules. 2s, it reacts with 2p molecules and produces sp2 hybridization. sp2 hybrid molecule. So hybridization of H2O is sp2, whereas in C2H2, carbon is 1s2, 2s2, and carbon atomic number is 6, 1s2, 2s2, 2p2. So it is, so it see, the hybridization of C2H2 is sp. Why? Because it includes triple bond. See, triple bond. So one 2s orbital, it reacts with one 2p orbital. So the S character in sp is 50%. The S character in sp2 is, it is 1 by third, that is 33%. So more the S character, more the S, more the acidic nature. So in comparatively H2O and C2H2, which has more acidic nature, C2H2. So H2O is less comparatively C2H2O and H2CO3 and phenol. That is option A. Sorry, it is option D. They're asking increasing order. It is option A. Next one, increasing order of acidic strength among the paramethoxyphenol, P-methylphenol, and P-nitrophenol. See, they're asking increasing acidic nature. It includes paramethoxyphenol, paramethoxyphenol, and paramethylphenol, and paranitrophenol. See, nitro group is a minus I group. So minus I means electron withdrawing group, electron withdrawing group, and CH3 is plus I group means electron releasing group, and OCH4, OCH3, it means minus I group along with plus M. What is plus M? It is plus M means plus R group. So plus M means electron releasing. In OCH3, it has comparative plus M is greater than minus I. So more the electron withdrawing, more the electron withdrawing, the bond polarity between OH is increased, which makes more easily to release electron. See, in case of paranitro, in case of phenol, this is nitro group. It is more electron withdrawing group, which makes bond between OH more polar, that is H plus one more. So it can be easily removed. So it has more acidic as compared to CH3 and OCH3. Or how can we compare between them? See, CH3 is plus I and OCH3 is comparatively more plus M. So plus M has more electron releasing nature as compared to plus I. So the acidic nature between methyl benzene, paramethyl phenol, acidic nature between paramethyl phenol and paramethoxyphenol in between do paramethylphenol has more acidic nature as compared to paramethoxy because it pronounce it and it has more plus R effect as compared to minus I effect. So it has less acidic nature as compared to paramethylphenol. So order will be paranitrophenol has more acidic nature as compared to paramethylphenol. It has more acidic as compared to paramethoxyphenol. So option A includes nitro, methoxy, and methyl. So it is wrong. Option B includes methyl, methoxy, nitro. It is wrong. Option C includes nitro, methyl, methoxy. Wrong. Option D includes methoxy, methyl, and nitro. Option D is correct. Next question. When phenol treated with excess bromine water, what does it give? See, whenever phenol treated with excess bromium, for example, phenol in the presence of carbon sulfide, what does it give? OH is electron withdrawing group minus I group. It has effect on ortho and para position. So whenever Bromine, it adds only at ortho and at ortho and para position. So Br plus OH and Br. See, in BrCH2, it only produce one bromine, that is monobromination reaction takes place. Monobromination reaction. And para bromine phenol is major as compared to first one, which is minor, because in this it has more steric hindrance. More steric hindrance. So para is major in case of monobromination. What they are asking, whenever phenol is treated with excess bromium, whenever phenol is treated with excess bromium excess, it produces tribromine, tribromine phenol, that is OH at 2 meta position, that is 2 and 6. At position 2 and 6 it gives bromine, and at fourth position it is 2,4,6 tribromo phenol. So in presence of bromine CH2, it gives monobromination reaction where para compound is major in quantity as compared to ortho compound due to steric hindrance in ortho position. Next, in case of excess bromine, it produces 3 bromine at ortho, para, and another ortho. So it gives 2,4,6 tribromophenol. It is option D. Next one. Which one of the following compound will be most readily attacked by electrophile? See, when electrophile, it is electron loving. It has some deficit. It has some deficit. With whom it reacts? Which has electron rich. So it reacts with nucleophile. So see, they are asking which of the following can easily react with electrophile. So option A includes chlorobenzene, option B is benzene, option C is phenol, option D is toluene. Toluene is CH3 on benzene group C. Cl and OH, these are electron withdrawing. So electrophile does not react with these things. In case of CH3, it is a nucleophile. It can release electron. So electrophile can react with toluene readily as compared to other things. So option will be D. Next one. Identify a product type of reaction. See, they gave benzene at first position. It has CO and Br. At first position, it has CO and Br. So it is a sign substitution reaction. There it is a sign substitution reaction. See, OCH3, the given product is 6 carbons are there, that is CO, C1, C, C, C. How many C's are there? C1 or between them? 1, 2, 3, 4. At fourth position, we have bromine. C. At first position, we have CO, and at fourth position, we have bromine. See, they're asking after this what will happen. See, it is a sign substitution reaction where OCH3 is reacted with NaNH2. Then it undergoes OCH3, and it undergoes here negative, and here it comes NH3 and it produces CH3 because double bond in between them. See, this is and OCH3 Br. See, it is a nucleophile Br negative. Uh, H plus should be removed from this. And in case of NaNH2, Na is positive and NH2 is negative. So NH2, where it can become, where it can come, see, it is Br is negative. So after removing, we can get positive here. After removing, we can get positive. After removing H plus from this carbon, because it is more acidic. These OCH3 and Br are more minus I effect. So the hydrogen between them is more acidic as compared to the position 4, 5, 6. So hydrogen at second position is more acidic, so it can be easily removed. So what does it conform? This it is positive. After removing, it is negative. It is OCH3. So it can form double bond here, double bond at this position. When this double bond is shifted, we can get positive here and negative here, positive and negative. So hydrogen will come here and it produces NH2. So Br is replaced by NH2. This is known as sign substitution reaction. See, at meta position we have Br and it is a methoxy benzene, and meta position we have Br. So after when it reacts with NaNH2, it produces negative. Hydrogen is removed. Hydrogen is removed at second carbon. After removing hydrogen, we can see the bond is formed between second and third carbon. So it produces double bond. After rearranging double bond, we can see at third position NH2 is formed. So it is known as sign substitution reaction. This is from my side. Thank you so much.